Welcome to this explainer. Have you ever wondered why your absolute favorite products are suddenly out of stock? Or, on the flip side, why massive companies can suddenly go bankrupt while they're sitting on giant warehouses completely full of unsold goods? It's almost never about the quality of the product itself. Actually, it all comes down to this hidden mathematical world, a really complex balancing act of production planning and fixed planning horizons that keeps supply chains running without completely draining the bank account. Today, we're going to decode that secret language.
So, here's our roadmap for today. We'll start with integrating the supply chain, then look at manufacturing and delivery strategies, compare level versus chase production, tackle the planning horizon problem, and finally, we'll solve the Queenstown case. Let's get right into it.
Part 1. Integrating the supply chain from macro to micro.
Think of the supply chain like this massive, invisible web connecting how information, inventory, and materials flow from the vendor right to the customer. A high-level sales and marketing plan literally cascades all the way down. It flows through distribution requirements planning, into master production scheduling, and finally hits material requirements planning and the actual purchase orders. Every single component, every subassembly, and every retail delivery is tethered directly to that initial sales plan. If one link snaps, the whole chain falls apart.
The absolute heartbeat of this entire operation is the Master Production Schedule, or MPS. It perfectly ties together production and sales. But here's the crucial thing you need to remember. It is a firm statement of planned future output. It's not just a hope or a wild guess about what demand kinda might be. It tells the sales team exactly when products will physically exist so they can make promises to customers that the company can actually keep. Moving right along to Part 2, manufacturing and delivery strategies, and specifically, moving the inventory block. Let's think about how a company's strategy shifts exactly when and where their inventory piles up. Take engineer to order, for example. The process stretches out linearly from design to procurement to manufacturing, assembling, and delivering. Sure, the customer ends up waiting a long time, but for the company, there is absolutely zero pre-built inventory sitting around eating up cash. Every single action is only triggered by a confirmed order. Now consider make to order. Here, the company actually holds raw materials or procured items in inventory right from the jump. They take on a little bit of financial risk holding those materials up front, but manufacturing doesn't actually start until the customer gives the green light. That ultimately cuts down the overall delivery lead time.
Step it up to assemble to order, and we see inventory happening much later. This means standard parts are already fully manufactured and are just sitting there waiting to be put together. Think of it like a custom computer build. The hard drives, screens, and keyboards are pre-built, and they just snap them together the second you finalize your online order.
And finally, we have make to stock. Here, the inventory is basically pushed right to the finish line. The product is entirely finished and ready for immediate delivery. This is fantastic for you as a customer. You just walk into a store, buy it, and take it home. But for the company, it ties up a massive amount of cash because they've already paid for all the labor and materials long before a single customer has handed over a dime.
All right, Section 3, Level versus Chase Production, the strategic dilemma.
Since we know where inventory lives, companies basically have to pick their poison between two extreme methods for managing it. Let's pit these two directly against each other. Level production is your steady, predictable factory life. You produce the exact same amount every single month. It's great for your workers, but if demand drops, boom, you build up excessive, expensive inventory. Chase production is the exact opposite. You manufacture only what is demanded that specific month. Your inventory stays near zero, but your factory floor is absolute hyper-responsive chaos with wild swings in hiring and firing just to meet those unpredictable demand spikes.
Because living in the extremes is pretty dangerous, companies usually go with hybrid strategies. They'll keep their core, in-house workforce humming along at a highly stable, level production rate. Then, when the chaotic variable spikes in demand hit, they just outsource or subcontract that extra work. It's all about finding that optimal sweet spot between keeping your workers happy and keeping your inventory costs low.
Which brings us to Section 4, the planning horizon problem. Let me introduce you to Queenstown Bikes. Let's step out of the theory and into a really concrete, granular problem. Imagine you are the manager of a fictional company called Queenstown Bicycles. You just landed a massive one-year contract to provide exactly 2,000 of your special Kiwi 99 Speedo bikes. It's a huge win. But now, you actually have to figure out exactly when to build these things over the next 12 months.
To solve this puzzle, we've got to navigate some seriously brutal cost constraints. The bike itself costs $50 to make. But every single time you turn on the factory machines for a production run, it costs you a flat $500 setup fee. And here is the real kicker: a punishing $1 per month holding cost for every single unsold bike just sitting around in storage.
Think about the delivery schedule they locked you into. It dips way down to just 50 bikes in the summer months of 4 and 5, and then absolutely spikes to 300 bikes in month 11. It's a wildly uneven demand curve, which basically sets up a nightmare scenario for your factory floor if you don't plan it out perfectly.
So let's get into Section 5, solving the Queenstown case by actually running the numbers.
Time for the math. Let's see how different production strategies either completely drain your bank account or save the company. We could use a few simple heuristics, which are basically just rule of thumb strategies, to figure out when to build these bikes. There's a brute force one-time run, a chase strategy like lot for lot, or more calculated approaches like fixed or periodic order quantities.
Say you take the easy way out. You do a one-time run. You build all 2,000 bikes in month 1 just so you only pay that $500 setup fee one time. Sounds smart, right? Well, congratulations on saving on setups, because you just got completely crushed by a staggering $13,100 in holding costs. Those bikes are just sitting in the warehouse all year. Your total cost balloons to $13,600.
Now, consider what happens when we systematically drop our costs by applying some smarter math. If we do lot for lot, making exact batches every single month, costs drop to $6,000. Periodic order quantity drops it to $4,000. And if we use an optimal mixed integer linear program, that's an advanced mathematical algorithm that tests every single possible variable to find the absolute minimum cost. Using that, we get the total cost down to just $3,850.
Comparing these strategies side by side really drives home exactly why supply chain math matters so incredibly much. The physical bikes didn't change at all. The factory didn't change. But simply switching from a lazy batch strategy to a mathematically optimized plan saves Queenstown Bicycles nearly $10,000 on a single contract. That is pure profit, generated 100% by smarter planning horizons.
So as we wrap up this explainer, I want to leave you with something to think about. The next time you buy a product, whether it's a bicycle, a smartphone, or literally even a box of cereal, ask yourself, what unseen mathematical battles were fought behind the scenes, balancing setup fees and holding costs, just to get that item into your hands at the exact right moment? And more importantly, how much money are your favorite brands leaving on the table right now through inefficient planning? Keep exploring, keep questioning, and I'll see you next time.